There you go.
Thank you. I don't speak Japanese nearly as good as Ian. I think I know maybe 5 words, one of which is biro, or beer, right? Please bear with me. If you have any questions, feel free to come up to me afterwards. And if you don't understand something, then I'm happy to explain it. Also, I have some stickers, but I only have a few stickers, so come up and grab some afterwards. Thank you. So I'm Michael Ducy. I run our open source projects at Sysdig. We have 2 main open source projects, one which is Sysdig, and then the one I'm going to talk about today, which is Falco. I used to work at Chef for a number of years, and then I've worked at Sysdig for a year and a half now. And if you want to reach out to me on GitHub or on Twitter, those are my handles, and my handle will be down in the corner on all these slides. So what is Falco? So Falco is, these are fancy marketing words. The easiest way to think of Falco is host intrusion detection. But it's host intrusion detection focused on Kubernetes and containers. So we use some of the libraries from our open source project Sysdig, and those libraries have the ability to go in and pull data from your Kubernetes API server or your container runtime environment. And then you can use that metadata that you get about pods and labels and namespaces to actually go and create rules that are specific to a particular namespace, or that are specifically towards a particular container image, or other things like that as well. The rules tend to focus around system calls and what system calls are allowed and disallowed on the system. So an important thing to note is that while we see the system call happening, we don't prevent the system call from actually executing. So it's just notification or detection, not prevention. So system calls include things like someone opening a network connection, someone writing a file, someone installing software after the container launches, other things like that as well. And I'll give a few examples here in a second. When we detect an abnormal behavior, then we can send a notification out to a variety of different places. Probably the one that's probably the best or gives you the more scalability is something like Fluentd or Logstash, which is actually geared towards taking streams of events and then pushing them off somewhere else. And it's open source, so anyone can contribute rules or improvements. And also along the lines of us being an open source project, we're being groomed, I guess you would say, in the CNCF as a sandbox project. They're helping us out with a number of things to grow the project and help us with things like security audits and other things like that that we wouldn't necessarily have the expertise to do ourselves. So if you want to learn more, you can visit the link there or just do a Google search. So let me kind of give you a comparison of how Falco works so that you can understand. So in the world of home security, we have things that prevent people from getting into the system. So we have door locks, window sensors, bars on the ground floor windows, although I haven't seen bars in my time that I've visited Tokyo. I haven't seen bars on windows very often. In the US, in like major cities, that's pretty common. Or exterior cameras, and I have seen exterior cameras. So once somebody breaks one of those ways that we prevent intrusion, we need to know that they're actually in the house or in the facility. So we have things like motion sensors and interior cameras that tell us that somebody has gotten into the house or the thing that we're trying to secure. So in the world of computers, we have the same thing. So we have things like passwords, two-factor authentication, which I have a funny story around that, but it probably wouldn't go over well. Or I couldn't explain it well enough. Container image scanning to make sure that we're not shipping vulnerable vulnerabilities in our containers. Admission controllers to prevent running things that we don't want to run in our Kubernetes cluster, so preventing a container or a pod from even starting to begin with. And then network policy, which provides next generation edge firewalling for Kubernetes clusters. And then in the world of Kubernetes, there's a bunch of commercial products that tend to focus on this idea of preventing behaviors in Kubernetes. There's things like Aqua and Twistlock, and then Sysdig has a commercial product as well. But our commercial product is built upon Falco, and we use the Falco runtime engine. So you can get some of the features of our commercial product for free by using our open source tool. And then there's also something which I'm going to talk about briefly, which is Kubernetes audit logging as well. And Kubernetes audit logging is very useful to see what's being allowed through your API server. So who's making the request, and getting more information about that request, whether that request was allowed or denied, and so forth. So anomaly detection in the world of containers, when we had many applications running on one single VM, and that VM was up for a really long time, and it was more of, everyone knows the pets versus cattle type analogy in the world of cloud. And so when we had these servers that were around for 5 years, that were running a lot of different things, it was very hard to do intrusion detection on those systems because people come in and they modify things, we don't have a record of it, and so forth. So with containers, it changes things greatly. It's an isolated process. It should be at least a minimal set of processes that are running inside of your container. We know what to expect from those processes, so we should only see processes manipulating certain files or reading from certain directories, accepting certain network connections on certain ports, initiating outbound connections on certain ports and other things, or to certain ports and things like that. So we can go and write rules much easier than we could in the old world when we had VMs that we were managing, or bare metal systems. The thing is that while containers are immutable, like the container image itself is immutable and you can't modify it, because if you modify it, then it becomes a new container image. The runtime environment isn't. So when the container spins up, that environment that the container gets, you can make modifications to the root file system, you can install new software, you can run additional processes and things like that that weren't necessarily expected when that container image was built. And that's part of the challenge is because the runtime environment isn't immutable. People can get into a container through a vulnerability or somehow, however they get a shell on the container. They can do things, they can install software, they can go and explore your environment, they can do data exfiltration, and then what happens when Kubernetes deschedules that pod or deschedules that container? You have absolutely no idea that somebody did all of that activity and did all of that behavior because that container is now gone, especially if you're cleaning up old containers as well and pruning the system or pruning the containers from your runtime. So the question is, how do you detect abnormal behavior in this very ephemeral environment? So a bit of history. Our founder came from the Wireshark community. He wrote WinPCAP and he contributed a lot of things into the Wireshark community. And one thing I didn't know until just a couple months ago, but there's a relationship between TCP dump and snort. The ability to capture network activity and have that capture interface where you can actually stream all those events, that actually gave birth to snort and being able to use PCAP to actually capture network activity and then write rules around that network activity. Now that's very similar to what we can do with Sysdig and Falco. So Sysdig is analogous to TCP dump and Falco is analogous to snort. And so what Sysdig does is it creates an event stream or a capture interface that allows you to capture all of the system calls that are going through the host. This is very useful because you can create a capture, you can then download that capture to your workstation, and then just like with TCP dump and Wireshark, you can read that capture and delve into what was actually happening on the system. There's a lot of performance and troubleshooting things that you can do with Sysdig in that capture. What we did with Falco is we used the same capture interface, and instead of just capturing and writing that information out to disk, what we do is we create an event stream, and then we have rules that we apply to that event stream to determine behaviors that we don't want to see. So let's talk about the architecture real quick. The typical way to run Falco, especially in a Kubernetes cluster, is to run it as a daemon set. We provide a Helm chart for you to install Falco as a daemon set. We also provide the daemon set as well in our GitHub repository. And what Falco will do is it will spin up, and then it will insert a kernel module into the host or the node's kernel. You can either have it dynamically compile a kernel module, or you can have it download a precompiled kernel module where you tell it to download the module from. You can also install it at the host level, so if you'd prefer not to have a privileged container running in your environment, then you install it on one of the worker nodes inside of your base image that you're using to provision your worker nodes. What happens is because, remember, there's the concept of a shared kernel on all of your hosts or all of your nodes. So because we're able to instrument the kernel that's shared by all the other containers, we're then able to see all the activity that's going through all of those containers. So every single time that it tries to spawn a process, open a file, network connection, and so forth. So a little bit bigger diagram of how Falco works. So we have this kernel module that creates this stream of events. The Sysdig libraries are used to parse that information, and then that goes into our filtering expression engine, which then also pairs with the rules to determine whether or not an event is abnormal. If it's a suspicious event, then we send it over to the alerting engine, which will then send the alert out to the appropriate output channel. We also run a small little web server as well. There's a couple web connections that are made. So the first web connection that's made is that you can specify the Kubernetes API server, and we'll go out to it to pull out data around what pods are running, deployments, namespaces, all of the data about what's actually running in your cluster. And then the second HTTP connection we have is the actual web server we run itself. And you can configure your Kubernetes master or API server to send the events into our web server, and then you can write rules around those events as well. So you can do two different things. So you can either trigger on Kubernetes audit events, or you can trigger on system call events, and I'll give you examples of both of those here in a second. So let's look at the rules and how the rules work. So here's a very basic example. So we have a couple different concepts in a rules file. So we have the rule itself, but then we have a couple helper objects. So the first one is a list, and the list is essentially just an array. This makes it easier because what if we start storing binaries in a different directory, and we don't want to have to go, we use that information in 100 different rules, and if I don't want to have to go update all 100 different rules because all of a sudden we started storing binaries in user local bin, all I need to do is update the list rather than going and updating all of the rules. So it's essentially a variable for us. Then we have what's called a macro, and the macro allows us to create shortcuts for conditions. And so you can see here that we create a macro called bender, and this condition basically says fd.directory is in binders. So this will get substituted and replaced in there. And so basically it's saying the directory for the event is within this list of bin, sbin, user bin, and user sbin, okay? And then we create the rule itself. And so the rule is basically saying, so the rule name, a description, and then the condition. So the event is doing something in a binary directory that we've defined up here. And then the event direction is closed, which I'll talk about that here in a minute. And something's been opened for writing, and we're not a package management process. So basically, somebody's tried to open something for writing that's underneath one of these directories, And it's not something like RPM or dpackage or something that we would expect to be writing binaries. Now, of course, this is a bad example for a container because you shouldn't necessarily be running apt and dpackage and other things like that inside of your container. But this will definitely tell you on the host file system whether if something changed. And then from an output, this is the actual message that gets sent out when an alert is detected. And so there's a couple other things that we do here. So you see the %sign username, %sign proc command line, and %sign fd.name. What this will happen is when the event triggers or when the rule triggers, this will get substituted and replaced dynamically with the user who ran the command, the actual command line that they ran, and then the file that they were trying to open for writing underneath your binary directory. Make sense? There's a whole host of these filter fields that you can use, so I kind of already covered that. Filtering expressions, it uses the same format as Sysdig. So that language that we just saw in the rule and in the macro and the condition, it's the exact same thing for Sysdig. So the nice thing is you can actually use Sysdig to actually determine what events you want to try and capture or alert on. You can run your container, you can create a capture, and then you can take that capture and then query it using the filter expression language to help you write your rules and make rule writing easier. Full support, as I already said, for container metadata, Kubernetes, Mesos, and Docker Swarm. What we do is we take all of the rules and we combine them into one big filtering expression joined by ORs. This means what will happen is that the first rule that triggers is the one that's, the first rule that gets violated is the one that will get triggered, and thus other rules down the chain may not necessarily get triggered on the event. So basically it's an event can only match one rule at a time. And then the other thing that's important is each rule must contain one event.type expression. So event.type are essentially just the system calls. So it would be open, accept, clone, exec.ve, things around spawning processes, opening files, accepting network connections, other things like that as well. All right, so let's talk about what the field classes are. One day I'll fix this slide. I've had to type this typo in this slide for, well, about 1.5 years now. This is supposed to be proc, not processes. So FD, file descriptors, processes, events, users, and groups, the container metadata, and then also the Kubernetes metadata, and then Kubernetes audit log events as well are all supported. So some quick examples, and sorry these color scheme doesn't work very well. But so the first one is container ID does not equal host. So basically I'm running inside of a container and proc.name equals bash. So somebody's running bash inside of a container. Somebody's overridden system binaries. So this is similar to the rule we saw before, but a little shorter. fd.directory in that list and write. Somebody's tried to change the namespace of a container. So somebody's calling the system call setns, and it's not in the process name of Docker or Sysdig. So we say Docker or Sysdig are allowed to make those changes. So anyone outside of that list, this rule would fire. And then I'll skip to the last one. Something that happens in all of your Kubernetes clusters, somebody's tried to open dev video. So that means they've tried to access a webcam and it's not Skype or WebEx. That happens in all of our containers, right? All right, so sending alerts, I've kind of already talked about this. So the Falco.yaml configuration file controls where you can send events. Probably the easiest one to do is either use standard out or file, and then use something like Fluentd or Logstash to pick up those messages out of standard out or out of the file that you're streaming to. The thing is that Logstash and Fluentd has a lot of features, especially around if you lose connectivity to where you're streaming the logs back, it will spool to disk and buffer for you. It also has some things around performance as well to make it more performant. So it's more of a better choice than trying to craft something yourself. We can also send to HTTP endpoint, which is a newer thing in 0.14. So let's look at another rule real quick. So this rule, we want to try and detect a process that's not node started in a node container. So somebody's spawning a process using the system call execve, and the container image starts with node. So there's a whole a bunch of conditions or logic that you can use for your rules. So we see equals, greater than, less than, all of those sorts of things. And then there's starts with, ends with, contains, other things like that as well. So the container image starts with node, and our proc name does not equal node. And then when that matches, we would get a rule that's fired off. So let's talk about Kubernetes audit log events real quick, and then I'll just give a quick demo of this, and then give you some examples of how you can use Falco as well. So it's a new feature in, I want to say 111, as I look at Dave Cheney for confirmation. You didn't do it. Okay, it's somewhere around 111. And what audit log events allow you to do is provide a record of events that are of actions that are making changes to your cluster. Each record is a JSON object. There's what's called audit policy to control what you actually want to log, so what actually gets pushed out to this to these logging events. And then there's log backends which control where events are sent. So you can just send it to a file and have something like Fluentd or Logstash pick it up. You can specify a webhook. And these two have to be configured, at least right now, they have to be configured on the master itself. And then there's a new feature that's alpha as of 1.13, which are called audit syncs. And this allows you to dynamically configure this. So one of the limitations is because in something like GKE or AKS or EKS or these managed services around Kubernetes, because you don't get access to the master, you can't go and make changes to enable this in that cluster. And so that's where audit syncs come in, where it gives you the ability to pull that information out without having to go and modify the master. So it's a nice new feature that'll open up a lot of use cases. 5 Kubernetes versions for audit syncs? Nice. Well, we're glad that it's finally on its way. So this is what an audit event looks like. So I just want to point out a couple key things here. So we have the verb, and so this is when you ran kubectl create or apply, delete, patch, whatever the verb is that you're using. You'll get that verb here. You get the actual URI of the API server that it's hitting. And then you get the username. You get a response code, whether if it was successful or not. And then you get an object reference. Now, you kind of have the object reference in your request URI, but this allows you to kind of break it down and get the actual keys out of it much easier. And so what was somebody trying to delete here? They were trying to delete a namespace named foo. Right? And then you get an audit ID, which is a unique GUID for every single record so that you can kind of uniquely identify every single action inside of your cluster. So what we did is, I did actually skip a slide, but what we did is we created a new generic event interface for Falco, and it can basically take any JSON data, and then we wrote a new Kubernetes event class, and what this allows us to do is kind of predefine a bunch of macros, or basically the language for you that you can use to actually filter on these types of events. And so you have some things like jevent.time, which allows you to access the event timestamp, but then we created a whole bunch of filter fields for you, so things like ka verb, kr URI, and so forth. And so what these basically do is they map to JSON pointers, and these JSON pointers allow us to go and very easily pull the data out of the JSON to create new new elements of the language. So this is actually a really big improvement because it makes it easier for us to support other event streams, which is one of the things on our roadmap. And then it makes it much easier for us to extend the native language of Falco or of Sysdig to actually support these types of events. If you run Falco --list k8s audit, you'll get back all of the filter fields that are supported by this new event stream. So let me show you another rule, and then I'll actually execute this real quick. So let's create a rule set around detecting somebody uploading private credentials as a config map. So the macro here says we create a macro called private credentials or contains private credentials. And the condition is that I'm a config map object that contains AWS access key ID, or it contains AWS S3 access key ID, or it contains a string password. Now this seems very, very basic, but how many times do breaches happen because somebody did something really, really silly like this, right? So we have another macro where we define a config map, which is KA target resource config maps. And then we create a macro called modify, which maps to KA verb in create, update, patch. So we need to create this macro called modify because there's multiple ways to modify something via the Kubernetes API. And then we create the rule itself. And so the condition, and this is a very good example because it allows you, it shows you how to use macros to make the rule much easier to read. And so the condition is, I'm a config map and somebody's modifying me and I contain private credentials. And so what will happen is we'll get this output, we'll get the user who did it, the verb, the thing that they were trying to modify, and then the other thing that we'll get is we'll get the actual data from the config map itself. So we don't scrub any data from the config map. The nice thing is in this example is that the key is now exposed, and the key needs to be rotated almost immediately because it's out there in a log or something. So it's not the best idea, but it's also not the worst idea because it forces you to rotate that credential. All right, so let me give just a quick demonstration of this rule. All right, so in this environment, I'm just running a Minikube cluster. And all I need to do is just do a kubectl apply, and I'll create my Falco daemon set. And kubectl get pods, and that's running. And then if I run a kubectl logs, you can see what happens is that in this case, I'm dynamically loading the kernel module, so it will attempt to build the kernel module for you, or it can attempt to download one from a repository that we maintain. You can override an environment variable and give it a URL, and that can be a kernel module that you provided and have built. And so you can see where it's built it, and then it's modded it, and installed it, and then Falco is up and running. So if I switch over to this other environment or this other terminal. Sorry, I installed completion in one, but I didn't install it in the other. All right, let me just grab that real quick. There we go. So let's get some rules to fire real quick. And so if I go back over to my other screen, you can see that we got a notification right away. We actually got 2 notifications. And this is one thing that I think is pretty interesting, being able to have 2 different event streams from 2 different sources, so you can actually kind of chase or trace the chain of events. So you can see here the first one is that a shell was spawned inside of a container with an attached terminal. This is actually a rule set that's based upon system call events. And so that's the first rule we got triggered. And then we got another event that was triggered, and this is via the Kubernetes API server. And And so you can see here that somebody is attached exec to a pod. We get the user. So up here, we're actually getting the user, or we're getting the user root. So they went into the container as root. We can see that the Minikube user is the one who ended up going into the container as root. And then when I did that touch bin hello, you can see that a file below a known binary directory was open for writing. And then let's get that other one to fire real quick. And I created the config map real quick. And you'll see, sure enough, that we did get this other rule fired right here. Warning, KDS config map with private credentials. And then you can see the actual raw config map as well. That was supposed to be foo, so my apologies. All right, so let me just talk about a couple more things because I know I'm running out of time. So I already kind of talked about how to install Falco, and I'll post these slides so you can use them as a reference later. And let's talk about just two things real quick about how you can use Falco. So we built a response engine with security playbooks. What this allows us to do is basically we publish alerts into a pub subsystem. In this case, we're using NATs. And then you can have different functions, using functions as a service framework like kubeless or Knative, subscribe to those different events on that pub subservice. And then you can also subscribe to different alert levels. So you could maybe take all alerts for something that's going to be logging, or you could do falco.notice for only notice events and so forth. And so we wrote a couple functions to do things like kill an offending pod, tainting nodes to prevent scheduling but leaving the node around so that you can then go and do forensics. You can isolate a pod with a networking policy and then send notifications via Slack. And then the last one real quick is we also wrote some content around how to build more of a SIEM. If you're familiar with the security space, it's the Security Information Event Management. And you can do that with Fluentd and Kibana. So let me just put up the roadmap help wanted slide, and then we can jump into questions if we have time.
じゃあマイクルさんありがとうございました。とりあえずその少しだけなんか、Q&A やろうかなと思ってますけど、質問は翻訳するので日本語でも大丈夫かなと思ってるんですけど、もし質問があったら須田さんが回ってくると思いますんで。
I'm Shinji. Thank you for good speech. 質問は日本語でいいですか？
大丈夫ですよ。
すみません。実際のセキュリティインシデントで、Kubernetes とか、コンテナで起きている、世界的な事例とかあったら教えていただけますでしょうか？
Like, do you have any examples of something that, like an actual exploit or something like that, that happened in the wild that this would catch?
One that we see a lot of is Bitcoin miners or cryptocurrency miners, and people getting into containers or Kubernetes environments. This will also catch things like if people are able to do privilege escalation and all of a sudden get root inside of a container or get into the host operating system and begin to modify things. There's also rules around like accessing the API server and you're not allowed to, and other things like that as well. And then we try to write rules around the CVEs that are coming out for Kubernetes and other components in the cloud native stack as well to try and do detection around those things.
ちょっと翻訳しますと、結構、具体的な、例としてはその結構 Kubernetes の API サーバーが、本当に、セキュアにロックダウンされてなくて、結構、ビットコインマイナーがワークロードを実行したりするっていうようなことが、すぐ分かるようなことだとか、あとは最近の、Kubernetes の CVE、なんかその実際の、その脆弱性に対して、Falco のルールを書いて、それを一緒に提供するっていうことにしています。はい。もしなんかもう一つぐらいの質問があれば。はい。
日本語ですいません。Falco ってそのカーネルモジュールを入れたりとか結構強い権限で動いていると思うんですけども、Falco 自身に問題があった時のセキュリティ対策とか、そのガバナンス体制っていうのがその何か問題があった時すぐ直しましたみたいな事例とか、かつてこんな問題があったみたいな話があったら教えてほしいです。
So he's saying that Falco itself seems to be run with like pretty high level of privileges. How would you kind of like how would you protect against it? And like, are there any like particular instances of around that have happened around Falco's security itself?
Luckily, not yet. We've not had any incidents. That's for good luck in America. You knock on wood. So, what was the first part? The other part?
Right. So, like,
you're running as a privileged container. You're mounting up a lot of things from the host. Typical things of networking policy, pod security policies, RBAC to prevent who can actually get into that particular container all still apply. If you are really concerned about it, you can always run it on the host level. So you're outside of kind of that container orchestrator level, and somebody has to get raw access into the host, and it's just not a container that they have to breach or break into. Yeah.
翻訳しますと、もちろんその Kubernetes のデーモンセットとして実行した場合は、Kubernetes の、セキュリティ機能を、適用されるので、そのセキュリティポリシーとかネットワークポリシーとか、ユーザーでその辺の、機能を使う、あとは、RBAC ですね、を使うといいと。で、あとはオーケストレーターで実行するっていうのは一番簡単なんですけども、自分でクラスターを作っている場合は、そのホストのデーモンとして、インストールして、運用するっていうのが、一つのやり方ですと。で、そうした場合は、実際にそのクラスターに動いているワークロードが、コンテナで、から、展開してそのホストに、侵入してしまうっていうような、ことが必要になってくるので、若干セキュリティ的には、マシなのかなっていうか、そっちの方が場合によっては、管理しやすくなるのかなっていう、ことですと。はい。
ありがとうございます。
じゃあこれで、このセッションを終わりにしたいと思います。マイクルさんありがとうございました。